Well, welcome to part 2 of this building a DCC model railway turntable. Now in the last section I dealt with the actual hardware, how to physically build this turntable. Now we're going to look at writing the code. But before we start, let's have a look at the turntable moving. Again, apologies for the video, it's done on my phone. So apologies again for the poor video quality, but as you can see the turntable works. Obviously I only have 4 positions, 2 exit tracks. There will be 2 tracks on the other end. I haven't actually installed the track yet, but as you can see it works and it indexes, and you'll notice that as it starts to move and then gets towards the end of the movement, you can hear the stepper motor have a slight change in tone. There is actually some acceleration and deceleration going in there because I didn't want it just to stop abruptly. Anyway, what we're looking at here on screen right now is the hardware. So underneath, under all of this, there is an Arduino Mega. I could have used an Arduino Uno, but I was a bit concerned because I was going to add points or turnouts, depending which country you're from, onto the same board. So what we have here is an old Shield that I had that already had a stepper motor driver on it, and this also already had the circuit that is needed to read the signal from the DCC controller. So what happens, obviously your DCC signal is sent down the track. You do not want to plug that straight into your Arduino board because it's going to be passing about 18 volts and you're going to let the smoke out of your Arduino. It's going to melt it. So we use what's called an opto isolator and a few other bits and pieces. On the Digital Town website there is a link to the Minabase site, which at the time of writing this, let me just check, the minabay.com website link wasn't working, so I've got a link to another site. I think it's actually a Dutch site, looking at the URL, but it's all in English and it looks like the same photos as the Minabay site, and it shows you how to build the circuit. There's a few other components that go around this that basically takes your DCC signal and converts it to a format that your Arduino can take without smoking itself. Always a good thing. Now, other things on this board, I've got the stepper motor driver. I've used an A4988 stepper motor driver. There are other ones and I will be experimenting with some others that are supposed to be quieter, but I know this one works and I'm happy to use it. One thing, when you start with your stepper motor, you'll notice just here there is a tiny little adjuster screw. Do some searches on eBay and stuff, on YouTube, and just have a look at how to adjust the stepper motor, because setting it up right really helps. I've then got a connector here that is coming from my photo interrupter, and then I've got a 12-volt power supply coming in here. So that would do most of the things that I needed to do. On this other board that I've sort of homemade and stuck on the end, there is a 5-volt DC power supply. This is because I've got servos being driven off here. If I tried to drive 5 servos off the Arduino, it would have been struggling. I also have a connection here that goes to some adjuster switches. Now these switches on mine I've used, was it capacitive touch sensors, because I just happen to have some knocking around, but you could just use standard push buttons. what these are used for is adjusting the position of the turntable, where just to move it backwards or forwards very slightly to fine tune the positions. Not 100% necessary, but it's a lot easier than trying to adjust everything in code every 5 minutes. So that is the basic hardware setup. Sorry, it's a bit of a messy photo, but now let's look at how I actually built the project. Now, as in the hardware build, I've put a lot of details on the Digital Town website just to go with this tutorial, so I'm not going to go into all the little details about everything because there's more information there for you to read. However, let's think about the main components that we're using here. So we've got a photo interrupter. There's a link on the site to some separate code on how to set that up. You've got the stepper motor, the buttons. I use the internal eprom on the Arduino. Now, eprom is some memory storage that is in the Arduino that doesn't get wiped every time the Arduino is restarted. So if you save some data into this tiny amount of memory, it's there for next time you start. And I use the eprom to store the turntable exit positions. That means that if I adjust them, next time I turn the system on, it's remembered the adjustments. And then, as I've mentioned before, we've got to have the circuit for the interrupt for the opto isolator to get the DCC signal. Now, one of the problems, and we'll start to look at the code now, one of the problems with working with an Arduino, very often when people want to do a project like this and it's their first time with an Arduino, they try and copy everything in one go. Now, the code is here, and hopefully you can butcher it and alter it. You can put more exits in, do what you want with it. That's not a problem, but I would advise you to work through a bit of a process to building this so you understand what's going on. So what I would tend to say to you is start off by setting up the photo interrupter, do some experiments. Again, there's some code already on the website to work out how that works, and just make sure that you can set that up and you can read the changes in values as you block the interrupter. Then what I'd say to you is set up your stepper motor. Get the stepper motor to just turn your turntable half a turn, or 2 seconds in one direction, 2 seconds in the other direction. Just get it so that you know that that stepper motor is running. It's a good time then to tune that stepper motor driver. Now, on my turntable, I'm using an 8th step. So as standard, if you just connect a stepper motor, it moves 1 step, but there's a way to get it to move half steps, quarter steps, 1/8 steps, or a 1/16 of a step. I use an 1/8 of a step because it creates a smoother rotation, which is quite important when you're moving your engines. So then once you've done that, then what I did was I combined the stepper motor code with the photo interrupter code, and I rotated the turntable until the photo interrupter got blocked, and then kept going until it got blocked the second time. That then gave me the exact number of steps that it takes for my turntable to rotate. Now, in my case, it was 25,600 steps per rotation. And what you may notice, especially if you're doing something like me with 1/8 of a steps or quarter of a steps, sometimes there will be an error. Now, I ran that piece of code probably 20-30 times, and then I averaged it out just to make sure, and I was getting an error of plus or minus 5 steps. Now, that might sound horrendous to you, but plus or minus 5 steps is actually 0.09 of a millimeter. It's nothing, and that's on a on my size turntable. If you're on a 12-inch or 300 millimeter diameter turntable, then it's going to work out at 0.18 of a millimeter. It's a tiny error, so don't panic if you get that, because actually it's just inevitable in anything you build that it's almost impossible to get the exact same measurement time after time. And to be honest, when the temperature changes, you'll get more expansion on your layout than you will get in that error. So that just sort of puts it into perspective. So once you then know how many steps it takes to get your stepper motor to rotate the turntable, I would then advise you, if you're going to use code as I've done, where I'm using a millis type system instead of delay for controlling the stepper motor, have a look on the code. Again, there's a link on the Digital Town website to how I've done this. The reason is, if you use delay in your code, if I tried to move a turnout or a point while the turntable is rotating, I won't be able to do it because the delay will block everything else out. So by using millis, I can turn points and I can have the turntable moving at the same time. So get that one done, and then have a go with eprom. Try writing some memories to the Arduino's internal eprom. Now if we look up here, if you want some examples of this, there are examples within the I've loaded the eprom library, and there are various examples I use the update. Update is better than write. If you write a value to an eprom, even if the value is the same as the value that's already there, it changes the value. Now unfortunately, the eprom will eventually wear out after about 100,000 writes. Doesn't sound much, but if you're updating it every few seconds, it'll quickly wear out. If you use update instead, when it writes, it's slightly slower. We're talking nanoseconds here, but it's slightly slower in that it checks the value, and if the value is different, then it will update, but if it's the same, it won't update. Therefore your eprom will last forever and a day, because I can't see you making 100,000 adjustments, not unless you've built a really bad turntable. So do some experiments, learn to read from the eprom, and then what I would tell you to do is build the circuit that is needed to read from the DCC track system. And then if you load a library, the library you want is the NMRA DCC library. So download that, build your circuit, and do some tests. And the example that's especially important to use is NMRA DCC accessory decoder 1. I'll just bring this up for you. Basically explain how this works. So there's a few things that you've got to do to set up the DCC. I'm not going to go through that at the moment, but then what happens, you can ignore that little bit, and we won't be needing that, but DCC process is called on the main loop over and over again, and this is basically the part that is looking out for a signal from the DCC decoder. And then what happens is you will get if you send a turnout signal from your controller, you will actually get one of these functions will basically print a result onto your serial monitor. And the function that we are particularly interested in, if we go down through our sketch, is the function, he says, there it is, notify DCC ACK turnout output. And that is the bit of code that we will actually use. So going back to this example, notify DCC accessory turnout output, that is the function we are interested in. What I then did was I deleted this function here, and to be honest, I deleted a lot of these other functions because I didn't need them. So yep, got rid of all of those. Got rid of that one as well. So basically I stripped the sketch down so that I had the absolute basics and that one notify DCC accessory turnout function is the one we're going to use. So you need to keep that and that one function in the main loop. Now once you've got that sketch working and you've got it stripped down, I'll be honest, I actually keep a version of that stripped down that I use for virtually all my Arduino DCC accessory decoders. It's a brilliant little sketch. Then it's a case of putting it all together. So let's have a quick look at what we're doing. We're going to start in the setup. I'm not going to go through every variable within this because you've got more time to look at that later, and if there's any questions, just email me. So I start off, get the serial running. Pin mode, I've got step pin and direction pin. Now you'll notice I use the enable pin. Now on the A4988 driver and most other drivers, there is an enable pin. No one tends to use it. The enable pin, if you don't connect it, then obviously the pin is low and the stepper motor runs. If you set it to high, and on mine I've got power off, which is a constant that I pass, which has a value of 1, it sets that pin high, and that disables the power to the stepper motor. You might think, well, why do you do that? Well, very often when I'm running the layout, the turntable might not run for half an hour, so why do I want the power on all the time? It's as simple as that. So then I just put some default directions in for the turntable. Next, I've initialized the two buttons that I use. I used capacitive touch sensors, but you know, you could use any old button. So I've set up the pin mode for those. Then we've got the first main function, which is get eprom data. Now if I go up to this function, just to give you an idea what it is doing. All right, get the eprom data. So what this does is it reads some values from the eprom, and the values that it's reading are the track exit positions. Now I've got 4 exits, and you'll notice I've got 8 values. I read 8 bytes. The reason is that you can only store information in bytes, so you couldn't write an integer, so you can only store a value up to 256. This is why it's worth looking at how eprom works. So you have to actually join 2 values together. One's called the high byte, one's called the low byte. You join these values together using this little line here, this equation, and then once I've got the track positions, I just print them out to the serial monitor. There's another function here, update eprom, that we'll look at later, that basically constantly updates the values. Now one thing I do in my code, you'll see that in my track positions array I have a set of default values. That's because the first time that you start the system up, you've got to have some kind of value in. Obviously if you've got 8 exits, you need to change that to an 8 and put 8 values in. But yeah, I put some default values in just to give me a starting point. Right, coming back down then. So now, if you like, we've read from the eprom. We now have stored in our array the exit values. I then start the DCC system here. And then on mine, the thing that I do immediately is I index the turntable. Now, I'm in 2 minds on this one, and I might change it later. If you index the turntable instantly, obviously it's immediately ready for use. The downside is if I lost power to the layout as a train was, or a loco was going onto the turntable, if the power's then restored, the turntable will instantly try and index itself while there's a loco that's half on and half off the turntable. Now, as I haven't had that problem at all while I've been running mine, I tend to index mine immediately. But it's just something to think about. You know, maybe it would be best to index it when you set your first track location. So what I do is I set the track direction to clockwise, and then I get it to move to track position 3. Now on my turntable, track position 3 is the last exit before the photo interrupter. And what this means is it forces, because my system will not find a location until it has been through the photo interrupter, it will keep turning. It'll then index itself and then turn all the way round to track position 3. And you'll notice I turn the power on once I've gone to this move track position, because otherwise yeah, I'm going to have a problem, aren't I, if the power's not turned on. Now that won't move during the setup. It actually moves during the main loop, and it's moved by this move turntable function, which we'll go into in a moment. So the first thing in the main loop is this DCC process. So the system is constantly looking for the latest signal that's coming through. On my final version, that can be for the turntable, or it can be for the points that are on the station board. Then we have this move turntable function. Now, as we've said, we've already set it to move to track position 3, and I've set a direction of clockwise. The reason I have done that is I've skipped some stuff in the DCC process. If I go into my DCC processing script, you can see I have moved to tracks position 100. This is to do with the fact that once the turntable starts rotating, I set this value of 100. When the turntable is set to move to a track, obviously it's moving to a low value. When the turntable stopped moving, I set this to 100. That tells the system that the turntable has arrived and therefore can start moving to another position. I don't want it to start moving to a second position before it's got to the first position. So when I've got my in the DCC thing, it tells me which track position I'm moving to. Then I've got something called get turntable direction, and that actually tells the turntable whether it's going to turn clockwise or anti-clockwise, you know, which is the quickest way to the new location. So that's how the DCC is sending this through. Now, as we saw here, I actually skip the find the track direction because I manually put it in here. That was deliberate because I wanted to ensure that it was always going to turn clockwise to go through that photo interrupter in the way that I wanted it to go. So if there is a position that the track's going to move to, that is picked up by this function move turntable, and we'll go up to this and have a look at how this works. So move turntable is basically just moving the turntable to its next position. Now, I don't use delay, so because if you've got delay, it's going to mess up any other code to do with turnouts and stuff with the servos. So I'm using a timer that's actually using microseconds. Now you'll notice here I put a value, if move to tracks is smaller than 5, because I've only got my sort of 4 turnouts. In fact, actually that should be smaller than 4, but obviously alter that number depending how many positions you've got. I've then got a step state. Normally when you're using delay, you will move the stepper 1 step, you'll set it the pin high, then you'll set the pin low. That's what this does here, and it uses this step state which constantly changes. As I've moved the steps, I increment the steps taken value. Now you'll notice here there's something to do with acceleration and deceleration, and basically what this does is as the motor starts or stops, it actually starts to alter the value of stepper timer. So the current stepper speed delay keeps getting altered. So there's values that are changing here to increase or decrease the speed of the turntable so it accelerates and decelerates smoothly. Just be aware, if you try and set the delay below above a certain amount or below a certain amount, your stepper motor will start to behave a little bit odd. So just watch how high or low the value gets and tune it according to your stepper motor. Now obviously as it's moving, I'm then incrementing or decrementing the step counter, so I know exactly where the turntable is. Another bit that's in here, as it's moving each step, it also reads the photo interrupter just to see if it has been blocked. If it has and the turntable is turning clockwise, and I only do it going clockwise, then it resets the step counter to 0, and that is my indexing. That's why when I started the turntable, it spins all the way around, it goes through that indexing point, and then I'm away, I'm started. Then what I do is it just happens to serial print out some information. If it's got to its final track position, it lets me know that it's arrived. It sets the current track position to the track position it's just moved to. Move to track positions goes to 100, so the system knows that it's not supposed to be going anywhere. And I've got a turntable index state equals 1 because I know that the system has been through the indexing point. Now there is a function there, by the way, you'll have seen, get turntable direction. If you look through that function, that works out which direction the turntable should turn depending on which track is picked next. Those basically control the whole turntable system. This next little function here is adjust turntable position settings. This was just so that I could fine-tune the turntable position using a couple of buttons instead of having to change the values in software. And all it does, if we go to this adjust the turntable positions, it sits there. Now you'll notice in here I am using delay. The reason I'm using delay in here, and I'm not worried about anything being sent from the DCC controller, is I can't be pressing the buttons on the DCC controller while I'm manually pressing buttons and adjusting the turntable position. I'm not that stupid and I'm not that clever. So all this does is it turns the stepper motor very, very slowly, and it alters the track position and the step counter position for the current track that the stepper motor, that the track is exiting from. So if you've created your system and when you're stopping at a track you find, oh my goodness, you know, it's like quarter of a millimeter out or whatever, this is the system that you can use just to fine-tune that final location. Now obviously as it updates the track position in the array, what we then need it to do is to store that permanently, and that is the last thing that I do in the main loop. So I've got a timer here that every goodness knows how long it takes, but every so many seconds or so it will update the eprom. Basically it calls the update eprom function that I wrote. He says, looking rapidly through the code, there we go, update the eprom, and this takes the values from the track position array and writes it to the eprom so that next time I start the Arduino it will remember any adjustments that I have made. So as you can see, it's not ridiculously complicated. It looks a lot of code, but if you've gone through and you've learnt to adjust each component one component at a time, putting it together is just a matter of a little bit of logic and some thinking about how you want the whole thing to work. I'll be honest, I've been very happy with the results that I've got. Its accuracy is unbelievable. In fact, I've disconnected the adjuster buttons because I'm just not using them. It just hits the perfect spot time after time, and that's pretty good. I went in the garage the other day when I actually did that little video of the turntable moving. My garage was only just above freezing and it had been well below freezing during the night, and yet that garage in summer will go up to 30 degrees C, and the thing works throughout all of those temperature ranges. One thing just to be aware of is that when you build your turntable, although you want the clearances to be as close as possible with the track, just bear in mind what temperature it is on the day that you do that. Because I did mine original one on a really cold day, and when I had a hot day, the track on the turntable had expanded and it did actually hit one of the output tracks. Anyway, I think that is about everything for this tutorial. If you've got any questions, I'm usually on the Arduino for DCC on Facebook, or you can send me an email through the Digital Town website and I'll get back to you on that. But I hope this tutorial has been helpful. I've gone through the code quite quick, but as I say, if you go through the Digital Town website, there's lots of examples there building up the code, and you'll see that when you look at the Hope Station version, it's basically the turntable version with some servo code added in that also controls the points. So if you want to understand how that works, take a look at that second example. Obviously do some experiments with servos first so you know how the servo library works. I just use the very basic servo library. So I hope that's been useful to you, and if it has, please click the like and subscribe, and I'll try and do another tutorial soon. Bye for now.